Okay, good morning. We have an online teaching on.
Good morning, sir.
Yes, thank you. On indeterminate forms. So let us have another indeterminate form now, that is infinity by infinity. So in the last class, I studied about 0 by 0 indeterminate form. But in this class, we have the indeterminate form infinity by infinity. Remember, infinity by infinity is also an indeterminate form. If f of x and g of x are two functions such that limit x tends to a is of f of x is infinity, and limit of g of x as x tends to a is also infinity, then limit of f of x divided by g of x as x tends to a is limit f dash of x whole divided by g dash of x as x tends to a. So limit of f of x divided by g of x as x tends to a, if it is of the form infinity by infinity, here also you have to do the same thing that you have done in your 0 by 0 form indeterminate. Limit f dash of x by g dash of x divided by x by x tends, limit x tends to a. Remember, it is you have to differentiate the numerator and also differentiate the denominator till the indeterminate form vanishes. So you have to continue the process till the indeterminate form vanishes. So in what we do in the many of the problems is we convert infinity by infinity into 0 by 0 form, and then we differentiate the numerator and denominator. Same procedure herein also. So that is, let us take one problem. Evaluate limit log of sin x by cot x as x tends to 0. Here first you have to substitute the limit and check whether it is of the form infinity by infinity. So if you put x equals 0 there, sin 0 is 0. Sin 0 is 0. Log 0 is what? Remember, log 0 is minus infinity, or actually you can call that as infinity. And cot 0 is infinity because it is 1 by tan 0. 1 by tan 0 is 1 by 0, which is infinity. So numerator is infinity, denominator is also infinity. Therefore, limit of log sin x divided by cot x as x tends to 0, because it is of the form infinity by infinity, you have to differentiate both numerator and denominator. What is differentiation of log sin x? Actually, differentiation of log sin x is 1 by sin x into cos x. That is cos x by sin x. What is cos x by sin x? Cot x. Cos x by sin x is cot x. Next, you have to differentiate cot x, the denominator. If you differentiate it, you will get minus cosecant square x as limit x tends to 0. Check again, it is, before that you can simplify this. What is cot x? Cos x by sin x. Cot x is what? Cos x by sin x. What is cosecant square x? It is 1 by sin square x. So if you simplify this, sin x cancels, you will get minus sin x into cos x. How have you got this step? By putting cot x equals cos x by sin x and cosecant square x equals 1 by sin square x. 1 sin x cancels and 1 sin x comes to the numerator. You will get minus sin x cos x as limit x tends to 0. Now put limit x tends to 0, check whether it is of indeterminate form. Sin 0 is 0, cos 0 is 1. You get 0 into 1 it is 0. So therefore, value of this limit is 0, though it is of the form infinity by infinity. Next, evaluate limit x tends to 0 log of tan x to the base x, remember, not to the base e, but to the base x. Consider limit x tends to 0 log x tan x. You can write this as logarithmic rule is there. What is the logarithmic rule? Log m to base n is nothing but log m by log n to the same base. Log m divided by log n. That is the rule of logarithm log m to base n. So using that rule, you can write this as log of tan x divided by log x. Check whether it is of indeterminate form. Yes, when x is 0, tan 0 is 0, log 0 is infinity, remember, by log 0, that is infinity, so it is of infinity by infinity form. Again, you have to differentiate the numerator and also denominator. Differentiation of the numerator, that is log tan x, is differentiation of tan x, 1 by tan x, 1 by tan x, into differentiation of tan x is what? Secant square x, whole divided by log x differentiation is what? 1 by x. Let us make use of our adjustment here. Bring that x to the numerator. You will get x by tan x, group this into secant square x can be written as 1 by cos square x. So secant square x is 1 by cos square x. Further, limit of x by tan x as x tends to 0 is always 1. Limit of x by tan x as x tends to 0 is always 1. Cos 0, you are putting x equals 0 here. Cos 0 is what? 1. So 1 by 1 into 1, that is 1. So the limit of this log tan x to base x is what? 1 as x tends to 0. Let us cite another example. Evaluate limit x tends to 0. Log sin ax by log sin bx. Log sin ax whole divided by log sin bx. You can write this as limit x tends to 0 log sin ax by log sin bx. That is the problem. Check whether it is infinity by infinity form. Yes, sin 0 is 0, sin 0 is 0, log 0 is infinity, log 0 is infinity. So yes, it is of the form infinity by infinity, which is indeterminate form. Next, you have to differentiate the numerator and also denominator using L'Hospital rule. That is L'Hospital rule. Log sin ax differentiation is 1 by sin ax, and differentiation of sin ax is a cos ax. Differentiation of sin ax is a cos ax. Similarly, in the denominator, it is 1 by sin bx. Remember, it's not cos bx, it is sin bx. So this has to be changed. You change yourself. So in the denominator, we have cos bx, you make it as sin bx. Sin bx, and differentiation of sin bx is what? B cos bx, b cos bx. Next, a by b is there, so a by b. Cos sin bx, this is sin bx comes to the numerator. So you get sin cos ax divided by sin ax is cot ax. And here cos bx by sin bx is cot bx. So I express this in terms of cot here. Next. Write cot in terms of tan because it is again infinity by infinity form. When x is 0, cot 0 is infinity. Cot 0 denominator is also infinity. So therefore, convert cot ax as 1 by tan ax. You can write cot ax as 1 by tan ax and cot bx as 1 by tan bx. That becomes to the numerator tan bx divided by tan ax. Now again it is of what form we have to check. When x tends to 0, tan 0 is 0. And when x tends to 0, denominator tan ax is also 0. 0 by 0 form. So again using L'Hospital rule, you have to differentiate this. You will get a by b. Tan bx differentiation is b secant square bx. Tan ax differentiation is a secant square ax. So therefore it is, what we have is b by a into when x is 0, secant 0 is 1 and this is secant 0 is 1. You will get b by a, you won't get 1. Remember, s you will get 1 because here you have one more a by b. So a by b into b by a, bb cancels. AA cancels, you will get 1. So here we are substituting secant 0 is 1, remember? Both in numerator and denominator it is 0, therefore secant 0 is 1. You will get A by B into B by A, which is equal to 1. Let us set another example. Secant pi x whole divided by tan 3 pi x as x tends to half. First you have to check whether it is indeterminate form, infinity by infinity or 0 by 0, that has to be checked. Then only you have to use L'Hospital rule. So by putting x equals half here, if you put x equals half, you will get secant pi by 2. Numerator is secant pi by 2. Secant 90 degree is what? Infinity. Secant 90 degrees, infinity. If you put x equals half in the denominator, tan 3 pi by 2, that is. Tan 3 pi by 2 is tan 270 degree, that is also infinity. So it is again infinity by infinity form. Next, you can convert this into sin and cos. How? Writing secant in terms of cos. You can write secant pi x as 1 by cos pi x. Remember, 1 by cos pi x is secant pi x. Tan 3 pi x is, tan you can convert into sin and cos. How? Sin 3 pi x by cos 3 pi x. So finally what you will get is cos 3 pi x whole divided by cos pi x into sin 3 pi x. Check whether it is of indeterminate form, taking limit as x tends to half. When x is half, cos 270 degree, because cos 3 pi by 2. Cos 3 pi by 2 is 0. And the denominator cos pi x, cos 90. Cos 90 is 0. And cos sin 270, because when x is half, sin 3 pi x is sin 270. That is also 0. So in the denominator also 0, numerator is also 0. It is of the form, indeterminate form 0 by 0. Now we have to differentiate this. Differentiation of cos 3 pi x is what? It is minus 3 pi sin 3 pi x. Denominator differentiation using product rule. Using product rule, you can write this as sin 3 pi x into differentiation of cos pi x is what? Minus sin pi x into pi. Plus. With the product rule, we have plus. Cos pi x into differentiation of sin 3 pi x is what? Cos 3 pi x into 3 pi. Now substitute the limit as x tends to half. Remember, not x tends to 0, but it is x tends to half. Put x equals half there. If you put x equals half, you will get minus 3 pi into sin 3 pi by 2. Sin 270 degrees minus 1, remember. Sin 270 degrees minus 1. 3 pi by 2 is 270 degree. Whole divided by minus pi into sin, when x is half, it is sin 90. Sin 90 is 1. Next term, sin 3 pi x tends to half is sin 270. Sin 270 is minus 1 plus 3 pi into cos 90. What is cos 90? Because when x is half, it is cos pi by 2. Cos 90 is 0. Therefore, entire term will be 0. Next, you have to simplify this. It is minus 3 pi divided by plus pi minus 3 pi divided by plus pi. Pi cancels. Divided by, therefore it is totally plus pi divided by plus pi, that is into 3. That is 3 pi divided by pi. 3 pi divided by pi, pi cancels, you will get the 3. So yes, it is the answer 3. Next, we shall take another problem on indeterminate form, infinity by infinity. Limit x tends to 0, log tan 2x to the base tan x. Remember, it is base tan x. Again, using that logarithmic fourth law. What is logarithmic fourth law? Log m to base n is log m divided by log n. So using that fourth law of logarithm, we can write this as limit x tends to 0, log tan x into tan 2x can be written as log of tan 2x divided by log tan x, letting x to 0. Check whether it is of infinity by infinity form. tan 0 is 0, log 0 maybe minus infinity, log tan x, it is also minus infinity, because when x is 0, tan 0 is 0. So minus infinity by minus infinity, that is nothing but it is infinity by infinity form. So again, it is indeterminate form. You have to differentiate both numerator and denominator using L'Hospital rule. First, differentiate the numerator. Differentiation of log tan 2x is what? 1 by tan 2x. Differentiation of tan 2x by chain rule, it is 2 secant square 2x. Whole divided by differentiation of log tan x is 1 by tan x. Differentiation of tan x is secant square x. Simplify this by converting tan into sin and cos, secant into cos, using 1 by tan 2x is nothing but cot 2x. But what is cot 2x? Cos 2x by sin 2x. What is secant square 2x? 1 by cos square 2x. What is 1 by tan x? Cot x. Cot x, how do you convert this into cos and sin? Cos x by sin x. What is secant square x? It is 1 by cos square x. Ultimately, if you simplify this, you will get 2 cos 2x cos square x sin x by sin 2x cos square 2x into cos x. Many of the terms will cancel, 2 cancels. Next, 1 cos x cancels. Next, sin 2x can be written as, okay, cos 2x cancels. So what you will get is 1 by cos 2x is left, because sin 2x is 2 sin x into cos x. What is sin 2x? It is 2 sin x into cos x. So that sin x also cancels. That cos x also cancels. So you will get 1 by cos 2x. Now take limit as x tends to 0. Cos 2 into 0, that is cos 0. Cos 0 is what? 1. You will get 1 by 1, which is equal to 1. So this is the limit of that. Let us take another problem. Evaluate limit x tends to infinity, x cos 1 by x by 1 plus x. Check whether it is of indeterminate form, infinity by infinity. That is the first step. In the first step, you have to check whether it is of the form infinity by infinity. By putting x equals infinity, remember, x tends to infinity here. Therefore, put x equals infinity. X is infinity. 1 by x, 1 by infinity is 0. Cos 0 is 1. 1 into infinity, therefore it is infinity. So in the numerator, you will get infinity. And in the denominator, 1 plus infinity is also infinity. Infinity, how the number says is the infinity. So we will get infinity. So infinity by infinity form. So therefore, you have to use L'Hospital rule. That is, you have to differentiate both numerator and denominator. In the numerator, you have to use product rule. What is product rule? U into dv by dx, thus v into du by dx. Similarly, first function is cos 1 by x. Second function differentiation x is what? 1. So I'll get cos 1 by x plus differentiation of, that is x into differentiation of cos 1 by x is what? Minus sin 1 by x. What is differentiation of 1 by x? That is minus 1 by x square. You will have 2 minus there. 1 is the differentiation of cos is minus sin 1 by x. And differentiation of 1 by x is minus 1 by x square. That minus into minus becomes plus. So what you will get is cos x, cos 1 by x plus x sin 1 by x into 1 by x square divided by 1 plus x. Differentiation is what? 1. Now limit is not been substituted here. You have to substitute. Limit is substitute ಮಾಡಿಲ್ಲ, substitute ಮಾಡೋಣ ಈಗ. 1 by infinity. X ಗೆ infinity substitute ಮಾಡಿದ್ರೆ 1 by infinity is 0. Cos 0 is to 1. ಅಲ್ಲಿಗೆ first term is 1 ಆಯ್ತು. Second term ಇದೆಯಲ್ಲ, x ಗೆ infinity ಕೊಟ್ಟಾಗ sin by 1 by infinity ಅಂದ್ರೆ ಎಷ್ಟು? 0. sin 0 ಅಂದ್ರೆ ಎಷ್ಟು? 0. ಅಲ್ಲಿಗೆ second term 0 ಆಯ್ತು. ಮೇಲ್ಗಡೆ 1 ಮಾತ್ರ ಉಳಿಯುತ್ತೆ. ಯಾವುದು? cos 1 by x into 1. 1 divided by 1 andre, so the answer is 1, remember. So answer is 1. So these are all the problems on what? Infinity by infinity form. Next, we shall take another indeterminate form, that is 0 into infinity. Remember, 0 into infinity is not 0. 0 into infinity is not 0, it is indeterminate. It is indeterminate. In this case also, what we actually do is we will convert it either into 0 by 0 form or the indeterminate infinity by infinity form. Kottiro problem usually we convert into 0 by 0 form or infinity by infinity form, and then we apply L'Hospital rule. So L'Hospital rule will be applied after converting that into 0 by 0 form or infinity by infinity form. So what the result says is, if limit of f of x as x tends to a is 0, remember first function limit is 0, and limit of g of x as x tends to a is infinity, second function limit is infinity, then limit of f of x into g of x as x tends to a, actually it is infinity, 0 into infinity, because first limit is 0, second limit is infinity. 0 into infinity is indeterminate form. Therefore, what we have is limit x tends to a, f of x into g of x can be written as 1 by g of x, 1 by g of x. Now substitute the limit here, limit x tends to a, g of x comes to the numerator. You can also write like this, g of x divided by 1 by f of x, g of x divided by 1 by f of x. The first one will be of the form 0 by 0 form, because the first limit is 0. Second, 1 by g of x is 1 by infinity. 1 by infinity is also 0. We'll get 0 by 0 form. Second one, g of x is infinity. Both the forms are same, remember. Veredu onde, but ಬೇರೆ ಬೇರೆ ಫಾರ್ಮಿಗೆ ಕನ್ವರ್ಟ್ ಮಾಡಿದೆ. ಬೇರೆ ಬೇರೆ ಫಾರ್ಮ್ ಅಂದ್ರೆ ಯಾವುದು? ಒಂದು indeterminate form 0 by 0 and another indeterminate form infinity by infinity ಗೆ ಕನ್ವರ್ಟ್ ಮಾಡಿದೆ. It is left to you. ನಿಮಗೆ ಬಿಟ್ಟಿದ್ದು, ನೀವು ಯಾವ್ದು ಬೇಕಾದ್ರೂ ಕನ್ವರ್ಟ್ ಮಾಡ್ಕೋಬಹುದು. Either you convert into 0 by 0 form or you convert into infinity by infinity form and then apply L'Hospital rule. L'Hospital rule apply ಮಾಡೋದು ಹೇಗೆ? Numerator differentiate ಮಾಡಬೇಕು. You have to differentiate the denominator also and you have to substitute the limit. Check whether it is indeterminate form again, and then you have to proceed by differentiating both numerator and denominator. That is L'Hospital rule, till you will get the final answer. That is a real answer. Next, before working problems on this 0 into infinity, let us have some more indeterminate forms and we'll work the problems at the end on all this. So indeterminate form infinity minus infinity. In this case also we change the form infinity minus infinity to the form 0 by 0 or infinity by infinity, and then we apply L'Hospital rule. Remember, infinity minus infinity is also indeterminate form. Remember here the function f of x as x tends to a is infinity, and the limit of g of x as x tends to a is also infinity. Then limit of f of x minus g of x as x tends to a is infinity minus infinity. So therefore it's indeterminate form. In that case we write f of x as 1 by f of x. Remember, 1 by f of x is nothing but f of x. In that case we write g of x as 1 by g of x. 1 by g of x. Next, this is 1 by g, or else you can also write this as 1 by g of x minus 1 by g of f of x, or 1 by f of x into 1 by g of x. No matter, while working problems you will understand this better. Then keep in mind that infinity minus infinity is indeterminate form. Conversion ಮಾಡೋದು ಹೇಗೆ ಅನ್ನೋದನ್ನ problems ಮಾಡಬೇಕಾದ್ರೆ it will be more lucid. Next, indeterminate form 0 power 0, 1 power infinity, infinity power 0. ಇದರ ಮೇಲೆ problems ಇದ್ರೆ ಮಾಡೋದು ಹೇಗೆ ಅಂತ. They are all indeterminate forms. 0 power 0, remember. 1 power infinity is not 1, remember, it is again indeterminate. Infinity to the power 0, that is also indeterminate. In this we do employ a technique, that is why we take logarithm. Okay, let us check. Consider limit f of x power g of x as x tends to a. Remember, limit of f of x to the power g of x as x tends to a. So first one limit of f of x as x tends to a 0 idre, limit of g of x as x tends to a 0 idre, allige enayitu 0 power 0 aitu. 0 power 0, again it is indeterminate. Limit of f of x as extends to a 1 idre, limit of g of x as extends to a infinity idre, aವಾಗ ಏನಾಯ್ತು ಇದು? This is 1 power infinity ಆಯ್ತು. That's also indeterminate form. ಮೂರನೇದು, limit of f of x infinity idre as extends to a, limit of g of x as extends to a 0 idre, ಅವಾಗ ಏನಾಗ್ತಿದ್ರು? ಪವರ್ infinity to the power 0 ಆಯ್ತು. ಇವೆಲ್ಲವೂ indeterminate form. In that case, what we do is, let y is equal to limit f of x as x tends to a g of x. We will take log on both sides. ಎರಡು ಕಡೆ log ತಗೋತೇವೆ. Log y left side ಅಲ್ಲಿ equals limit x tends to a log of a raised to m ಇದ್ರೆ ಬರೆಯೋದು ಹೇಗೆ? m log a ಬರೀತೀರಾ, ಹಾಗೆ g of x log f of x. ಈಗ ಇದು ಯಾವ ಫಾರ್ಮಿಗೆ ಬಂತು ನೋಡೋಣ ಅಲ್ವಾ? Which is of the form log of g of limit of g of x as x tends to a is to in ಎಲ್ಲ ಕೇಸಲ್ಲಿ 0. ಅಲ್ಲಿಗೆ this is 0. Log of f of x, remember it is infinity, limit substitute ಮಾಡಿದಾಗ infinity, again it is 0 into infinity form. ಇದನ್ನು ಚೇಂಜ್ ಮಾಡ್ಬೋದು ಹೇಗೆ? 0/0 ಅಥವಾ infinity by infinity ಗೆ ಚೇಂಜ್ ಮಾಡ್ಬೋದು ಹೇಗೆ? ರೆಸಿಪ್ರೋಕಲ್ ಅಲ್ಲಿ ಬರೆದಾಗ ಇದನ್ನು 1/g of x ಬರೆಯೋದು, ಇದನ್ನು 1 log of f of x ಬರೆಯೋದು, ಇದನ್ನು 1/g of x ಬರೆದ್ರೆ ಅವಾಗದು ಈ ಫಾರ್ಮ್ಗಳಿಗೆ ಬರುತ್ತೆ. ಬೇಡ ಪ್ರಾಬ್ಲಮ್ ಮಾಡ್ಬೇಕಾದ್ರೆ ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ದಿಸ್ ಕ್ಲಿಯರ್. ವಾಟ್ ವಿ ಹ್ಯಾವ್, ಇದರ ಲಿಮಿಟ್ ಏನೋ ಬರುತ್ತೆ ಗೊತ್ತಿಲ್ಲ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಿದಾಗ, ಯಾಕಂದ್ರೆ ಪ್ರಾಬ್ಲಮ್ ಏನು ಅಂತ ಕೊಟ್ಟಿಲ್ಲ. g of x f of x ಅಂತ ಜನರಲ್ ಆಗಿದೆ ಬಿಟ್ರೆ ಪರ್ಟಿಕ್ಯುಲರ್ ಪ್ರಾಬ್ಲಮ್ ಕೊಡದೇ ಇರೋದ್ರಿಂದ ಇದರ ಲಿಮಿಟ್ ಮಾಡಿದಾಗ ಏನೋ ಒಂದು ಫೈನೈಟ್ ಲಿಮಿಟ್ ಬರುತ್ತೆ ಯೂಸಿಂಗ್ ಲೋಸ್ಪಿತಾಲ್ ರೂಲ್ ಯೂಸ್ ಮಾಡಿದಾಗ ಒಂದು ಲಿಮಿಟ್ ಬರುತ್ತೆ. ಆ ಲಿಮಿಟ್ ಗೊತ್ತಿಲ್ಲ ಅನ್ನೋದನ್ನ ವಿ ಶಾಲ್ ಕಾಲ್ ದಟ್ ಆಸ್ ಎಲ್. ಸೊ ಲಾಗ್ y ಈಕ್ವಲ್ಸ್ ಎಲ್. ನಮಗೆ ಬೇಕಾಗಿರೋದು y ಲಿಮಿಟ್ ಬೇಕಾಗಿತ್ತು ಬಿಟ್ರೆ ಲಾಗ್ y ಅಲ್ಲ. ಅವಾಗ y ಬರ್ಬೇಕಾದ್ರೆ ಏನ್ ಮಾಡ್ಬೇಕು ಹೇಳಿ? ಲಾಗ್ ತೆಗಿಬೇಕು ಅಂದ್ರೆ ಆಂಟಿ ಲಾಗ್ ತಗೋಬೇಕು ಅಂದ್ರೆ y ಈಕ್ವಲ್ಸ್ e ಪವರ್ l, ಯಾಕಂದ್ರೆ ಇದು ಬೇಸ್ e. therefore y ಈಕ್ವಲ್ಸ್ e ಪವರ್ l is the answer. ರಿಮೆಂಬರ್, ಈ ಪ್ರಾಬ್ಲಮ್ ಮಾಡ್ಬೇಕಾದ್ರೆ ಫಸ್ಟ್ ಲಾಗ್ ಕಂಡಿಡ್ಕೊಳ್ತಿರಲ್ಲ, ವಾಪಸ್ y ಬರ್ಬೇಕು. y ಹೇಗೆ ಬರುತ್ತೆ? e ಪವರ್ l. ಲಿಮಿಟ್ ಏನ್ ಬಂದಿರುತ್ತೆ ಅದಕ್ಕೆ e ಪವರ್ ಹಾಕಿದ್ರೆ ಆಯ್ತು. ಕೆಲವೊಮ್ಮೆ ಎಕ್ಸಾಮ್ ಅಲ್ಲಿ ಯೂಶುವಲಿ ಬಹಳ ಜನ ತಪ್ಪು ಮಾಡ್ತಾರೆ, ಲಾಗ್ y ಈಕ್ವಲ್ಸ್ ಎಲ್ ಬರ್ತಾರೆ ಅಲ್ಲಿಗೆ ನಿಲ್ಲಿಸ್ಬಿಡ್ತಾರೆ, ಮುಂದಿನ y ಈಕ್ವಲ್ಸ್ e ಪವರ್ ಎಲ್ ಮಾಡೋದೇ ಇಲ್ಲ. ದೇ ವಿಲ್ ಲೂಸ್ 1 mark. ಸೊ ಲೆಟ್ ಅಸ್ ವೆರಿಫೈ ದಿ ಫಾಲೋಯಿಂಗ್ ಪ್ರಾಬ್ಲಮ್ಸ್. Evaluate limit x tends to 0 cosecant x minus cot x. So evaluate limit x tends to 0 cosecant x minus cot x. Wait for 1 minute, 1 second. Yes. What is cosecant x? Cosecant x as x tends to 0, cosecant 0. Cosecant 0 is infinity, remember. Cot 0 is also infinity because it is 1/tan 0. So infinity minus infinity, which is indeterminate form. Further, cosecant x can be written as 1/sin x. Cosecant x can be written as 1/sin x. Cot x can be written as cos x by sin x. Now take limit x tends to 0. Further, you can simplify this by taking the LCM. What is the LCM there? Sin x is the LCM. You will get in the numerator 1 minus cos x. ಈಗ ಇದು ಯಾವ ಫಾರ್ಮಲ್ ಇದೆ ಅಂತ ಚೆಕ್ ಮಾಡ್ಕೊಳ್ಳೋಣ. ಆನ್ಸರ್ ಹಾಗೆ ಡೈರೆಕ್ಟ್ ಆಗಿ ಬರ್ಬೋದು, ಬರ್ದೇನೂ ಇರ್ಬೋದು. ಡೈರೆಕ್ಟ್ ಆಗಿ ಬರಲಿಲ್ಲ ಅಂದಾಗ ಡಿಫ್ರೆನ್ಶಿಯೇಟ್ ಮಾಡಬೇಕಾಗುತ್ತೆ. ಅದಕ್ಕೂ ಮೊದಲು ಇದು ಯಾವ ಫಾರ್ಮಲ್ ಇದೆ ಅಂತ ಚೆಕ್ ಮಾಡೋಣ. Put x equals 0 here. Cos 0 is 1. 1 minus 1, 0. So it is 0. Numerator is 0. What about denominator? Sin 0, 0, 0. Therefore 0/0 form. ಮತ್ತೆ ಇದು indeterminate ಆಯ್ತು. ಅಲ್ಲಿಗೆ you have converted this problem infinity minus infinity to 0/0 form. Next you have to use L'Hospital rule. How do you use L'Hospital rule? Differentiate 1 minus cos x. 1 is 0. Cos x is minus sin x. Already one minus ಇದೆ. Therefore sin x divided by differentiation of sin x is what? Cos x as x tends to 0. ಇಲ್ಲೇ ಬೇಕಾದರೂ ಲಿಮಿಟ್ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡ್ಬೋದು, ಯಾಕೆಂದ್ರೆ sin 0 is 0, cos 0 is 1, 0 by 1 andre 0. Adu beda andre sin x by cos x is tan x. As x tends to 0, tan 0 is 2, tan 0 is 0. Therefore, the answer for this one is 0. Next, we shall take another problem. Limit x tends to 0, 1 by x square minus 1 by x tan x. First, you have to check whether it is an indeterminate form of what form? 0 by 0 or infinity by infinity or infinity minus infinity or something like that. Because you have several forms of indeterminate. So limit x tends to 0, 1 by x square minus 1 by x tan x. When x is 0, 1 by 0. 1 by 0 is what? Infinity. When x is 0, tan 0 is also 0. This is 0, 1 by 0, that is infinity. Again, it is of the form infinity minus infinity form. For that, you have to convert it into some other form, 0 by 0 or infinity by infinity form. For that, what we do is we take the LCM. What is the LCM for x square and x tan x? It is x square tan x. And here in the numerator, it is tan x. In the numerator, it is tan x minus x, because LCM is x square tan x. Further, in order to use L'Hospital rule, now it is again 0 by 0 form, because when tan 0 is 0, this is 0. This denominator is also 0, it is 0 by 0 form. In order to use L'Hospital rule, to make L'Hospital rule easy, or simplification is easy, we shall adjust one thing. What is that we have to adjust? You have to multiply and divide the denominator by x. Denominatorly, you have to multiply by x and also divide by x. ಅವಾಗ ಏನಾಗುತ್ತೆ ಅಂದ್ರೆ x ಕ್ಯೂಬ್ ಆಗುತ್ತೆ, x ಸ್ಕ್ವೇರ್ ಇದು ಮಲ್ಟಿಪ್ಲೈ ಮಾಡಿದಾಗ, ಡಿವೈಡ್ ಮಾಡಿದಾಗ ಇದು tan x by x ಆಗುತ್ತೆ. ಇಟ್ ಇಸ್ ನಥಿಂಗ್ ಬಟ್ x by tan x. tan x by x ಡಿನಾಮಿನೇಟರ್ ಬಂದಾಗ ಅದು ನ್ಯೂಮರೇಟರ್ ಬರೆದರೆ x by tan x ಆಗುತ್ತೆ. ಯಾಕೆಂದ್ರೆ ಇಲ್ಲಿ x by tan x as limit x tends to 0, 1 ಆಗಿ ಒಂದು ನಂಬರ್ ನಮಗೆ ಡಿಫ್ರೆನ್ಶಿಯೇಟ್ ಮಾಡೋದು ಮುಂದೆ ಕಡಿಮೆ ಆಗುತ್ತೆ, ಅದಕ್ಕಾಗಿ. So x by tan x as limit x tends to 0 is 1. ಅವಾಗ ಏನು ಉಳಿಯುತ್ತೆ? tan x minus x by x cube ಉಳಿಯುತ್ತೆ, because limit of x by tan x as x tends to 0 is 1. ಮತ್ತೆ ಇದು ಯಾವ ಫಾರಮ್ ಅಂತ ನೋಡೋಣ. When x is 0, tan 0 0 minus 0 divided by 0 cube 0. That is again it is 0 by 0 form. What is the differentiation of tan x? That is secant square x. Differentiation of x, that is 1. Divided by 3x square as x tends to 0. ಇಲ್ಲಿಗೂ ಮುಗಿಲಿಲ್ಲ. ಯಾಕೆ ಮುಗಿಲಿಲ್ಲ ಅಂದ್ರೆ secant 0 is 1. 1 minus 1 0. Divided by 3 into 0 0. 0 by 0 ಫಾರಮ್ ಈಗ ಬಂತು ಮತ್ತೆ. ಆದ್ರಿಂದ L'Hospital ರೂಲ್ ಎಲ್ಲಿವರೆಗೆ ಇದನ್ನು ಯೂಸ್ ಮಾಡಬೇಕು ಅಂದ್ರೆ ನೋಡಿ, 3x ಸ್ಕ್ವೇರ್ ಇರೋದು 6x ಆಗುತ್ತೆ, 6x ಇರೋದು 6 ಬರೋವರೆಗೆ ನಾನು ಡಿಫ್ರೆನ್ಶಿಯೇಟ್ ಮಾಡೋದು ಅನಿವಾರ್ಯ ಆಗುತ್ತೆ. ಸೊ ವಾಟ್ ವಿ ಹ್ಯಾವ್ ಇಸ್ ಡಿಫ್ರೆನ್ಶಿಯೇಷನ್ ಆಫ್ secant square x, 2 secant x into secant x tan x. That is nothing but 2 secant square tan x. Differentiation of 1 is 0. Differentiation of 3x square is 6x. Next, this is limit x tends to 0. ಇಲ್ಲಿ ಅಡ್ಜಸ್ಟ್ ಮಾಡ್ಕೊಳ್ಳೋಣ ಈಗ. secant square x 2 by 6 ಅಂದ್ರೆ 3 divided by 3 ಒಂದ್ ಕಡೆ ಸೇರಿಸೋಣ. tan x by x ಒಂದ್ ಕಡೆ ಸೇರಿಸೋಣ. as limit x tends to 0. ಈಗ tan x by x as x tends to 0 ಎಷ್ಟು ಗೊತ್ತು ನಮಗೆ? 1 ಅಂತ. ಇದಕ್ಕೆ 1 ಬರೆದ್ಬಿಡೋಣ. ಏನು ಉಳಿಯುತ್ತೆ? x ಗೆ ಲಿಮಿಟ್ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡೋಣ ಈಗ. secant 0 ಎಷ್ಟು? 1. 1 by 3 ಅಂದ್ರೆ it is 1 by 3. So therefore answer is 1 by 3. So let us work many more problems. We have several problems here. So I have to work all these problems in the next class. For the time being, I shall conclude this. Okay, right? So do you have any doubts?
No, sir.
Okay, right. So I shall conclude this meeting.